Now we come to the session 22. So already familiar in Cauchy theorem, Cauchy integral theorem in form of to evaluate line integral and path integral. By using Cauchy integral theorem, now we come to the consequence of Cauchy integral theorem. It is a statement. So if f of z is analytic in a region D, if PQ be any 2 point in R, then integral of P to Q f of z dz is independent of path joining P and Q. So integral of P to Q f of z is independent of a path joining P and Q. That is, say integral of P to Q f of z dz is same for all curve joining P and Q. The whole curve joining the point P and Q. First, we take a curve in the xy planes. So first, if we take a point PQ, the curve joining P to Q, like from I call this C1, then P to Q call as C2. So these are two curves we obtain PAQ and PBQ form. See the direction, we observe the direction is important here. The curve C1 and C2 be a two simple closed curve joining P and Q. C1 and C2 be simple closed curve joining the point P and Q, such that both the curve lies in the region R. Thus, this is the region XY region. The curve region lies in the same region. So, then there is a union. Then there is a union PAQ BP. See, observe this is the direction PAQ BP. Become the simple closed curve in the region R. Become a simple closed curve in the region R. Now, by the Cauchy's theorem in the already known the previous slide, integral of f of z dz equal to 0. Say Cauchy's theorem. So, see the path. Integral of PAQ f of z dz plus QBP integral of QBP f of z dz equal to 0, because by using the Cauchy theorem, so we splitting the region in the same region, the curve C1 and C2. Say the curve C1 PAQ f of z dz plus QBP f of z dz equal to 0. Say integral of PAQ f of z dz, if you change the directions, instead of QBP, I'm changing the PBQ. So direction if change, so negative of that. So minus integral of PBQ f of z dz. That is, the curve PAQ represent C1, the curve PBQ represents C2. That is, integral of C1 f of z dz minus integral of C2 f of z dz equal to 0. That is, say curve C1 f of z dz is equal to curve C2 f of z dz. So integral of P to Q f of z dz is independent of path of integrations. See, this is the curve, the direction, and the Cauchy theorem says. See, the region is xy region. The curve, so I call C1 from PAQ. The same region QBP, I call C2. But direction, if you go like this, if we sum to total integration is 0. So direction. So that is say integral of P to Q f of z dz is independent of path of integration. So come to the second. Say we take a region in a bounded a simple closed curve in a region. Say if C1 and C2 are two simple closed curve, if C1 and C2 be the simple closed curve such that C2 lies entirely with C1, C2 lies entirely with C1. And if f of z is analytic inside, on the boundary of a annular region and the boundary of a annular region between C1 and C2, then integral of C1 f of z dz is equal to integral of C2 f of z dz. See, observe, if you take a annular region, so suddenly C2 2 lies entirely C1. C2 lies entirely C1. But a direction is observed. Let us, we observe this direction. We observe it. C1 moves, we observe the directions. Let us introduce the cross cut in the form of a line segment. Cross cut in the form of a line segment. Say the line segment PQ, the line segment PQ with the point P on C1. See line PQ, the line segment cut, cross cut line segment. P lies on the curve C1, Q lies on the curve C2. That is a PQ with the point P on C1 and Q on C2. That is a curve. We say that's a curve P R S P Q A B Q P. That is, let's say, if you take a curve, the connection between C1 and C2, C P R S P Q A B Q to P, as shown in figure. So the simple closed curve f of z is analytic inside and boundary. So f of z is analytic inside and boundary C. Hence, by Cauchy's theorem, say integral of f of z dz equal to 0. So C is boundary, is analytic, suddenly is a Cauchy's satisfy integral of C f of z dz equal to 0. Since C is a union of the arc, see if we take a total C is a union of arc P R S P and P Q and Q A B Q and Q P. See, observe this, there are union of curves P R S P, one curve, P Q is another curve, Q A P Q is another curve, and Q P is another curve. That is, we denote integral of C1 f of z dz plus PQ integral of f of z dz plus curve inside the curve. I call this C2, but direction is negative, so minus C2 f of z dz plus QP integral of f of z dz equal to 0. That is, say integral of C1 f of z dz plus integral of PQ f of z dz minus C2 f of z dz. So I am taking the reverse order. Instead of Q to P, I take P to Q. So minus P to Q f of z dz equal to 0. See here C1, see your P, your positive sign integral of P, PQ f of z dz, a negative sign integral of P to Q f of z dz get cancelled. So integral of C1 f of z minus integral of C2 f of z dz. That is, if take this side. So integral of C1 f of z dz is equal to integral of C2 f of z dz. See, this is the Cauchy is applicable. Cauchy integral theorem is applicable in a closed curve. Then if we come to the extension of Cauchy theorem, and say if we take this curve, a curve in corollary form, corollary 1, if we say, suppose f of z is analytic in a simple connected domain D. So f of z is analytic in a simply connected domain D, then the integral along any rectifiable curve in D joining any given points of D in the same, joining any given point of D is the same. That is, it does not depend upon the curve joining the points, joining the two points. That is, say, suppose if you take a curve joining two points, suppose if you take a two curve A of z1 and B of z1, if you take two curve, if you take a join A and B, so if you associate a point z1, so A of z1 and B of z1 simply connected a domain D or joined by the curve C1 and C2. So simply connected a curve, the same the previous figure, the same. If you call A of z1 and B of z2 connected in a domain D, I join the curve C1 and C2 as well. Then by Cauchy's theorem, say integral of f of z dz, integral run from A, L, B, M, A. So this direction is upward. So take A, L, M, B, M, A. So again the direction A, L, M, f of z dz plus B, M, A, f of z dz. So this is if it just changes the direction, integral of ALM f of z dz minus AMB f of z dz. That is say, if we take a curve C1 f of z dz minus this curve C2 f of z dz. That is say, if we take this side, integral of C1 f of z dz equal to integral of C2 f of z dz. This the same Cauchy is applicable. This is proves a required result. In another corollary, it says if you multi-connected region forms, it says so if a closed curve is continuous. So the corollary 2 says let a closed counter C contain another closed curve counter C1. So let a closed counter curve C contain another closed counter C1. That is, let f of z be analytic at every point lying in the ring shape domain bounded by C and C1. Bounded by C and C1. So, see, then integral of C f of z dz is equal to integral of C1 f of z dz. Means integral of the outside boundary is equal to integral of the inside boundary. That is, this is the Cauchy's the corollary form. So we take a curve, take a graph. See, observe this graph. So curve C and curve C1 here. The curve C, we make a cross line joining between A counter C, T, the point A and E, the cross cut line joining between the curve C and C1, AE. So curve joining between A, C and C1. That is say, we make a cross at joining the point A of the counter C to the point E of counter C1. So this is the line joining between A and B, the counter C to counter C1. So by Cauchy's theorem say integral of, we observe the integral of A, B, C, D, A, E, F, G, E and A. This is the area is connecting between counter C to C1. That is say A, B, C, D, A, E, F, G, E, A. That is the f of z dz. You say that is the curve C represent integral of A, B, C, D, A, f of z dz plus AE, f of z dz plus E, F, G, E, f of z dz plus EA, f of z dz. That is a, so this is the reason. So, but integral of AE, f of z dz is equal to minus EA, f of z dz. That is this area, the sum should be the, so that integral of AE, f of z dz plus EA, integral of f of z dz. So, that is integral of A, B, C, D, E, f of z dz plus integral of E, F, G, E, f of z dz equal to 0. That is say, so integral of C, f of z dz minus integral of E, F, G, E, f of z dz. That is total integral C1 f of z dz is equal to integral of C1 f of z dz. This is the consequence of a Cauchy integral theorem says outside the curve should be equal to inside the curve C1. So, and if we come to simple problems regarding the Cauchy criteria, Cauchy, so that integral of C e power minus 2z dz is independent of path C, joining the point 1 minus pi I to 2 plus 3 pi I. So 1 minus pi I to 2 plus 3 pi I and determine its value C. Observe, first if we take a graph joining between 1 minus 2 pi I and 2 plus 3 pi I. So see, this is a tag. So take x-axis, y-axis. They point 1 minus pi I to 2 plus 3 pi I. So this is a line. Again draw that point. We get integral of I is integral of C f of z dz is equal to f of z is given function e power minus 2z, e power minus 2z, and C is a straight line joining the point. C is a straight line joining the point 1 minus pi I to 2 plus 3 pi I. 1 minus pi I to 2 plus 3 pi I. Evidently, f of z is differentiable. So f of z is differentiable everywhere in a z plane. So f of z is differentiable everywhere in a z plane. Hence, f of z is analytic entire in z plane. F of z is analytic entire in z plane. Therefore, by a previous corollary in a Cauchy corollary, so Cauchy's theorem, say f of z dz is independent of path integrations. This is independent of path integrations. Say independent of path integration you calculated. So integral of c f of z dz. So integral of c f of z dz is equal to integral from 1 minus pi I to 2 plus 3 pi I e power minus 2z dz. So start integrating this, become minus 1 by 2 e power minus 2z. Z varies from 1 minus pi I to 2 plus 3 pi I. So that is minus 1 by 2 e power minus 2 times of 2 plus 3 pi I minus e power minus 2 times of 1 minus pi I is equal to, simply say, is equal to minus 1 by 2 e power minus 4. This is e power minus 4 minus e power minus 2. So this will, so simply we get this is e power minus 6 pi I equal to 1 equal to 2 pi I, because if we open this here, e power minus 4 e power minus 2, yeah, e power minus 6 pi I minus e power 2 pi I. So if you come to the Cauchy either formula, so e power 6 pi I is cos 6 pi I plus I sin 6 pi I. So if you get the cos the sign, multiple of sign is 0. So we get cos 6 pi I is 1, again cos 2 pi I is 1. So this is sin pi, all multiple of sin pi is 0. That is, we get e power 6 pi I is 1, e power 2 pi is also 1. That is, we get integral of c f of z dz should be equal to 1 by 2 times of e power minus 2 minus e power minus 4. So minus, if we take minus and outside, it becomes positive. Let we come to the problems in the form. So I equal to integral of c f of z dz equal to, so integral of line AB plus integral of line BC. That is, totally we get the equation of line AB is y equal to minus pi, y equal to minus pi, z equal to x plus iy. So y equal to y, so x replace y by pi, suddenly we get x minus pi I, dx equal to dz. So this is called integral of 1 should be equal to integral from 1 to 2 e to the power of minus 2 times of x minus pi I difference dx equal to, so is e power 2 pi I, integral from 1 to 2 e power minus 2x dx. That is 1 times of integral from 1 to 2 e power minus 2x dx. Again, we start integrating with respect to x, we get e power 2x divided by minus 2. X varies from 1 to 2, we get minus 1 by 2 e power minus 4 minus e power minus 2. So this is the same value here. So the required BC is, the required line BC equal to, if x equal to 2, z equal to 2 plus iy, dz equal to I dy. So integral of minus pi to 3 pi is e power minus 2 times of 2 plus iy, I dy. So again simplifying, say take I outside, then start integrating with respect to y. So this is I times of e power minus 4 divided by minus 2 e power I minus I to pi y varies from minus pi to 3 pi. So that is, we substituting a value minus I by e to e power 4 of e to the power of minus 6 I pi minus e to the power of minus I pi to pi. So totally is 0. So this is, this value e power 6 pi I is equal to 1, e power minus 2 pi I is 1. So totally is 0. That is, integral of c f of z dz equal to I1 of line AB2 plus I2 of BC. Total values should be 1 by 2 times of e power minus 2 minus e power minus 4 plus 2 times plus 0 times. So this is the values of that. This is the line integral is the same along the different path. So for line AC, that is line AB plus line BC. So if the integral of line AC is the same as the integral of line AC, integral of line AC is same as integral of AB plus BC. So integral of BC plus BC. So this is the line AC is equal to line AB plus line BC. So this is the line is integrals is independent of the path. This is the Cauchy. By using the Cauchy theorem, which